Now we are going to discuss volume mole relationship. Volume mole relationship. All right, so in volume mole relationship, the triangle is like this. All right, so we have given volume on the top, and here to the left side we have moles, and here the quantity is 24 dm cube. It is 24 dm cube, or it is 24,000 centimeter cube. All right, this is I'm going to tell you regarding this quantity in a while. So basically, first of all, volume mole relationship is applicable only on gases. It is only applicable on gases. Applicable on gases. All right, so for example, if we have gas which is hydrogen H2, and another gas is we have oxygen O2, and another we have chlorine Cl2. All right, so hydrogen H2, oxygen O2, and chlorine Cl2. Okay, so the mass of hydrogen is 2 grams. The mass of hydrogen is 2 grams. The mass of oxygen is, as the atomic mass of oxygen is 16. This is you can see from the periodic table. Oxygen, the mass of atomic mass of oxygen is 16. So 16 multiplied by 2 is 32. So this is 32 grams. AR of chlorine is 35.5. So when 35.5 is multiplied by 2, we get 71 grams. All right. So as these masses are expressed in grams, as it is expressed in grams, so it is equals to 1 mole. It is equals to 1 mole. All right. So this is equals to basically 1 mole. Okay. So 1 mole of any gas, when 1 mole of any gas at room temperature and pressure occupies 24 dm cube volume, which is known as molar gas volume. All right, so definition of molar gas volume would be molar gas one mole of any gas at room temperature and pressure. The abbreviation of room temperature and pressure is RTP. So 1 mole of any gas at room temperature and pressure occupies 24 dm cube, or 24, if it is in centimeter cube, it is 24,000 centimeter cube volume. It is known as molar gas volume. So when 1 mole of any gas at room temperature and pressure occupies 24 dm cube volume, this 24 dm cube volume is known as, this 24 dm cube volume is known as molar gas volume. All right, so room temperature and pressure. So what is meant by room temperature and pressure? So the standardized room temperature is, you need to learn the values. So the standardized room temperature is 20 degrees Celsius. Room temperature is 20 degrees Celsius, and standardized pressure is 1 atm. 1 atm. Atm represents 1 atmosphere. It is 1 atmosphere. It is 1 atmosphere. All right. So this pressure, which is 1 atm, 1 atm means it is approximately equals to 100,000 pascals. 1 atm means it is approximately equals to 100,000 pascals. So this is the standardized room temperature and pressure all over the world. So this is the standardized room temperature and pressure all over the world. Room temperature is 20 degrees Celsius and pressure is 1 atm, which we are experiencing right now as well. So this is the pressure which we are getting, and room temperature is 20 degrees Celsius as it is the standardized all over the world, because certain places have they might have different room temperature, but if we take the average, so the average standardized value is considered as 20 degrees Celsius. So the room temperature is 20 degrees Celsius and the pressure is 1 atm, and molar gas volume is 24 dm cube. If it is in dm cube, it is 24 dm cube, but if it is in centimeter cube, it is 24,000 centimeter cube. All right. So when 1 mole of any gas at room temperature and pressure occupies 24 dm cube volume, so it is known as molar gas volume. Okay, so if we need to find the moles of any gas, okay, so what would be the formula then? As we have mole over here, so formula would be volume. So moles, to find moles of any gas, it would be volume as it is on the top divided by 24 dm cube. All right, if the given volume in the question is in dm cube, we need to use 24. So volume in dm cube divided by 24, or if the given volume is in centimeter cube, so then what are we supposed to do? Volume in centimeter cube divided by, so then in that scenario you need to divide it by 24,000. Okay, so this is the formula of finding moles. All right, now let us do worked examples of it. Okay, so given that the volume of carbon dioxide gas is 15 dm cube at room temperature and pressure, find number of moles. Okay, so now they say given that the volume of carbon dioxide, so the given volume of carbon dioxide in the question is 15 dm cube. So 15 dm cube is the given volume. Okay, and we need to find moles. So the formula would be, we would use this formula according to the triangle, volume in dm cube divided by 24. Okay, so moles is equals to volume divided by 24. So now here the volume is 15 and the molar gas volume is 24. So when we divide 15 by 24, we get 0.625 dm cube. All right, if the scenario is changed and they say the volume of carbon dioxide is not 15 dm cube, it is instead 20,000 centimeter cube. Let us suppose if in the question they say they have given the volume in centimeter cube. So what are we supposed to do now? So we need to use the relevant formula, which is mole is equals to volume, as the given volume is in centimeter cube, so we will divide it by 24,000. We will only divide it by 24,000 instead of 24. Okay, so the given volume is 20,000 centimeter cube. 20,000 divided by 24,000. All right, so when we do the division process, 20 divided by 24, so we get 0.833. now the unit would be 0.833 moles. Sorry, the unit here is moles as well. It is not dm cube as we were finding moles, so it is 0.625 moles. All right, now let us do another word example. They say that given that the mass of carbon dioxide gas is 22 grams. Given that the mass of carbon dioxide is 22 grams, find the volume at room temperature and pressure. All right, so now in another example they have given us the mass of carbon dioxide, which is 22 grams. All right, so you know whenever we solve gases based questions, we only use volume mole relationship, but here they have given us the mass. So it means as we need to have volume, so to find volume, what do we need to have? To find volume, so this is the volume over here. So to find volume, we need to multiply moles by molar gas volume, which is 24. So to find volume, so the formula for volume would be, volume would be mole times 24. All right, so now we only have mass, we do not have moles. So it means first of all we convert it to the moles. Then afterwards we use this formula to find the volume. All right, so to convert the given mass into moles, as it is the mass, so we would use mass mole relationship. So first of all, according to the mass mole relationship, to find moles we divide mass by molar mass. We find to find moles we divide mass by molar mass. So given mass in the question is 22 grams. All right, and the molar mass or molecular mass of carbon dioxide. All right, so carbon is 12. According to the periodic table, the mass of carbon is 12 and the mass of oxygen is 16 times 2, as we have two atoms of oxygen, so here it will be multiplied by 2. Okay, so 32 plus 12 would be 44. So to find moles, mass divided by molar mass, so 22 over 44 we get 1 over 2, which is 0.5 moles. All right, so this is the moles of carbon dioxide is 0.5. Okay, now we need to find the volume. So the formula for the volume would be moles times molar gas volume, which is 24. So the calculated moles are 0.5. So when 0.5 is multiplied by 24, we get 12. So here now we are finding volume. So we would write its unit as we have used 24. As we have used 24 dm cube, so the unit would be dm cube as well.